Welcome to this model. Today we are going to discuss about application layer paradigm. It should be clear that to use the internet we need two application programs to interact with each other. One running on a computer somewhere in the world and the other running on another computer somewhere else in the world. And the two programs need to send messages to each other through the internet infrastructure. And there are two paradigms which are called client-server paradigm and peer-to-peer paradigm. Let us see one by one. Although there are several ways to achieve process-to-process communication, the most common one is through the client-server paradigm. A process on the local host called a client needs service from a process usually on the remote host called a server. Both processes, that is client and server, have the same name. For example, to get the day and time from a remote machine, we need a daytime client process running on the local host and a daytime server process running at the remote machine. Operating system today support both multi-user and multi-programming environments. A remote computer can run several server programs at the same time, just as local computers can run one or more client programs at the same time. For communication, we must define some terms called local host, local process, remote host, and remote process. Whenever we need to deliver something to one specific destination among many, we need an address. At the data link layer, we need a MAC address to choose one node among several nodes if the connection is not point-to-point. And a frame in the data link layer needs a destination MAC address for delivery and a source address for the next node's reply. At the network layer, we need an IP address to choose one host among millions. A datagram in the network layer needs a destination IP address for delivery and the source IP address for the destination reply. So at the transport layer, we need a transport layer address called a port number to choose among multiple processes running on the destination host. The destination port number is needed for delivery and the source port number is needed for the reply. In the internet model, the port numbers are 16-bit integers between 0 and 65,535. The client program defines itself with a port number chosen randomly by the transport layer software running on the client host. This is ephemeral port number. And the server process must also define itself with the port number. And this port number, however, cannot be chosen randomly. If the computer at the server side runs a server process and assigns a random number as the port number, the process at the client side that wants to access that server and use its services will not know the port number. Of course, one solution would be to send a special packet and request the port number of a specific server, but this requires more overhead. The internet has decided to use universal port numbers for servers, and these are called well-known port numbers. So there are some exceptions to this rule. For example, there are clients that are assigned well-known port numbers, and every client process knows the well-known port number of the corresponding server process. So in client-server paradigm, the service provider is an application program called the server process, and it runs continuously waiting for another application program called the client process to make a connection through the internet and ask for the service. The service process must be running all the time. The client process is started when the client needs to receive the service. The examples of client-server model is email, network printing, and the World Wide Web. So this is an example of the client-server paradigm. The main disadvantages of client-server paradigm are the server should be a powerful computer. Even a powerful computer may become overwhelmed if large number of clients try to connect to the server at the same time. Another problem is that there should be a service provider willing to accept the cost and create a powerful server for a specific service, which means the service must always return some type of income for the server in order to encourage such as an arrangement. And several traditional services are still using this paradigm, including WWW, that is World Wide Web, and its vehicle HTTP, Hypertext Transfer Protocol, File Transfer Protocol, SQL, email, and so on. And the next paradigm which we are going to see is about peer-to-peer. In this paradigm, there is no need for a server process to be running all the time and waiting for the client process to connect. The responsibility is shared between the peers. A computer connected to the internet can provide service at one time and receive service at another time. So it can act both as client and as well as server. A computer can even provide receive services at the same time. Example, Ubuntu, Linux Mint, and Manjaro. So this example shows the peer-to-peer paradigm which is connected through multiple devices. And the main challenge has been security. It is more difficult to create secure communication in this mode between the distributed service than between those controlled by some dedicated servers. The other challenge is applicability. It appears that not all applications can use this new paradigm. And now let's move on to client-servant programming. So in the client-servant paradigm, communication at the application layer is between two running applications program called process. That is a client and a server. A client is running program that initializes the communication by sending a request. A server is another application program that waits for the request from a client. The server handles the request received from a client, prepares a result, and sends the result back to the client. So this definition of a server implies that a server must be running when a request from a client arrives, but the client needs to be run only when it is needed. However, we need to be careful that the server program is started before we start running the client program. So we can say that the lifetime of a server is infinite and it should be started and run forever waiting for the clients. The lifetime of the client is finite. It normally sends a finite number of requests to the corresponding server and it receives the responses and stops. If we need a process to be able to communicate with another process, we need a new set of instructions to tell the lowest 4 layers of the TCP IP suite to open the connection, send and receive the data from the other end, and close the connection. So a set of instructions of this kind is normally referred to as an application programming interface or API. And there are 3 types called socket interface, transport layer interface, and stream. Let's see one by one. The idea of sockets allows us to use the set of all the instructions already designed in a programming language for other sources and sinks. For example, in most computer languages like C, C++, or Java, we have several instructions that can read and write data to other sources and sinks, such as a keyboard. Keyboard is a source, and a monitor, which is a sink, and a file in source and sink. So we can use the same instructions to read from or write to sockets. So this is the position of the socket interface, which is placed in between the application layer and transport layer in both client side and server side, right? And this is how sockets are used the same way as the other sources and sinks. So although a socket is supposed to behave like a terminal or a file, it is not a physical entity like them. It is an abstraction. So it's an object that is created and used by the application program. A socket address should first define the computer on which a client or a server is running. A computer in the internet is uniquely defined by its IP address, a 32-bit integer in the current internet version. However, several client or server processes may be running at the same time on a computer, which means that we need another identifier to define the specific client or server involved in the communication. And this is how socket address is defined. So it defines for example, 32 bits defines the IP address and 16 bits defines the port number. In UDP communication, the client and server use only one socket each. The socket created at the server side lost forever, and the sockets created at the client side is closed or destroyed when the client process terminates. Now let's see an example which shows the lifetime of the sockets in the server and the client process. In other words, different clients use different sockets, but the server creates only one socket and changes only the remote socket address each time a new client makes a connection. So this diagram shows the sockets used for UDP communication, and this one is socket, and this is a response which is given to the server. Now let's see the sockets used in TCP. The TCP server uses two different sockets, one for connection establishment and the other for data transfer. We call the first one as the listen socket and the second as the socket. A server uses listen socket to listen for a new client trying to establish connections. After the connection is established, the server creates a socket to exchange data with the client and finally to terminate the connection. The client uses only one socket for both connection establishment and data exchange. So here you can see how sockets are used in TCP connection. And now let's move on to World Wide Web. World Wide Web is an interconnected system of public web pages accessible through the internet. The idea of web was first proposed by Tim Berners-Lee in 1989 at CERN and the European Organization for Nuclear Research. And this idea is to allow the several researchers different locations through Europe to access each other researchers. The commercial web was started in the early 1990s. The web today is a repository of information in which the documents called web pages are distributed all over the world, and related documents are linked together. The popularity and growth of the web can be related in two terms. In the above statement, they are called distributed and linked. Now let's see one by one. Distribution allows the growth of the web. Each web server in the world can add a new web page to the repository and announce it to all internet users without overloading few servers. Linking allows one web page to refer to another web page stored in another server somewhere else in the world. The linking of web pages was achieved using a concept called hypertext, which was introduced many years before the advent of the internet. The idea was to use a machine that automatically retrieved another document stored in the system when a link to it appeared in the document. The web implemented this idea electronically to allow linked documents to be retrieved when the link was clicked by the user. Now today the term hypertext coined to mean linked text documents has been changed to hypermedia to show a web page can be a text document, an image, an audio file or a video file. Today the web is used to provide electronic shopping and gaming. One can use the web to listen to radio programs or to view television programs whenever one desires without being forced to listen to or view those programs when they are broadcast. Now let's see the architecture of the World Wide Web. So this diagram shows the architecture. The World Wide Web today is a distributed client-server service in which a client using a browser can access a service using server. However, the service provided is distributed over many locations called sites. So we can say simply World Wide Web is a repository of information linked together from points all over the world. And each site holds one or more documents referred to as web pages, and each web pages can contain a link to other pages in the same site or at other sites. The pages can be retrieved and viewed by using browsers. Now let's go through the scenario. Like the client needs to see some information that it knows belongs to site A. It sends a request through its browser, a program that is designed to fetch the web documents. The request and among other informations includes the address of the site and the web page called the URL. And the server at site A finds the document and sends it to the client. when the user views the document, she finds some reference to other documents also, including a web page at site B. So the reference has the URL with the new site, and the user is also interested in seeing this document. The client sends another request to the new site and the new page is retrieved. And this is how website is retrieved and seen. A variety of vendors offer commercial browsers that interpret and display a web document, and all use nearly the same architecture. Each browser usually consists of three parts: a controller, a client protocol, and interpreters. The controller receives input from the keyboard or the mouse and uses the client programs to access the document. After the document has been accessed, the controller uses one of the interpreters to display the document on the screen. The client protocol can be one of the protocols, and the interpreter can be HTML, Java, or JavaScript. Depending upon the type of document, we can modify them as a client or server. The web page stored at the server will be stored at the server, and each time a client request arrives and the corresponding document is sent to the client. To improve efficiency, servers normally store requested files in a cached memory. Memory is faster to access than disk. A server can also become more efficient through multi-threading or multiprocessing. So in this case, a server can answer more than one request at a time. Thank you.